It's another math day here with teacher Jenny. Join me for another discussion, and this time we are standardizing our row scores for a normal distribution. So let's have the first problem. Okay, the problem is the average age of a company's president is 56 years old. Assume the variable is normally distributed. If the standard deviation is 4 years, find the probability that the age of a randomly selected president will be less than 58 years old. So again, since our mean there is not equal to 0 and our standard deviation is not equal to 1, so we are going to undergo standardizing. So let's know the given. Our mean is 56 and our standard deviation is 4. So you have there the average and also the standard deviation as your keyword, that will be your mean and standard deviation respectively. Now next, we have our 58 years old. This is your x value. So we have x equal to 58 for that one, and we are going to standardize. So standardizing, we have that equal to x minus the mean over the standard deviation. So plugging in, we have our 58 as your x minus our mean, which is 56, divided by 4 as our standard deviation. So this is now equal to 2 over 4, or this is simply equal to 0.5. So this will be our z-score. So what we are looking for here is the probability that the age of a randomly selected president will be less than 58 years old. So we are simply looking for our area, as our z will be less than our 58, which is our x value. We converted that out to 0.5 as your z value. So that will be with this one. So we have our probability of z less than 0.5. So let's try to find that out. Okay, once again, we have our z equal to 0.5, and we are looking for our p of z less than 0.5, because it says there choosing a president with less than 58 as the age in there. So what to do when you are looking for the probability here? We are simply looking for the area in which our z value is less than 0.5. So again, finding the area, you have to always follow the SSS or the OSA. If you do not know this one yet, you try to go back to my video, which is found on the description below, the video of my finding the area, in which I'm using there the SSS or the OSA. So again, how to use the SSS or OSA here? Simply looking at the direction of your area, or where is your area located, you can just simply look at the symbol and its tail there, where it is pointing to. This tail here is pointing towards the left side, so your area is on the left tail. And then we have our z value, which is 0.5, which is positive, and it is located on the right side. So once again, we have left and right. They are with opposite direction. Oh, we know that one. They are with opposite direction. So if that's the case, we are simply following the opposite side, then we add. So what are we adding? Since we have only one z value here, which is 0.5, we'll be adding the area corresponding to that one to your 0.5. So adding or finding, locating that one on the z table. We have this one here as 0.5. And your area is this one. So that will be the area that you are going to add up on your 0.5. So you're adding 0.1915 and adding that up. This is equal to 0.6915, or this is now equivalent to 69.15%. Now, if you are to illustrate that up to check, just to check whether you are correct in adding those areas, then we might as well plot it or illustrate that one here on the normal curve. We have 0.5 that is somewhere here. And if I'm going to attach or to connect a line to that curve there, and it says here, z is less than 0.5, the z values that are lesser than 0.5 are always located on the left side. So the area that we're looking for is this area that is attached to the left tail. Okay? And since your area is not connected to the center, or it does not begin with the center going to the left side, then that means to say we're simply adding this one here, the area from 0 until 0.5 with the entire area on the left curve, which is 0.5. So that is why this is really, really correct when we're adding 0.5 and so with the 0.1915. Okay? So I hope that works fine. Now, what does it mean when we have 69.15%? So there is a greater chance that we will be choosing a president of the company which is less than, or which is with less than 58 years old as the age. I hope you were able to follow through. Now, next, we go for another example. We have here the average length of time in minutes a student answers a 10-item true or false test is 15 minutes and the standard deviation is 2 minutes. Suppose there are 50 students who took the test. What percentage of the students spent 16 minutes or spent below 16 minutes answering the test? So again, we are going to know our given there. We need our mean, our standard deviation, and also our x value. So we have our mean as 15. That is according to this problem. We have the average length of time in minutes. That is with 15 minutes. And of course, standard deviation is 2. Our x value is the one in which we are looking for the percentage of the student that spent below that 16 minutes. So this is our x. So standardizing, this is now z equal to x minus the mean over the standard deviation. Our x is simply 16, our mean is 15, and standard deviation is 2. So we have that one as 1/2, or this is equal to 0.5. So this is our z-score. Now, when you say below, it means we are looking for the area that is below your 0.5, meaning to say it's an area towards the left side because all the values of z that are below 0.5 are always on the left side. So when you say below, when you have keywords below here, that is similar to when you say to the left. I hope that's clear, everyone. So let's now look for P of z less than 0.5. Again, this is similar to the previous example that we had. Sorry on this. I did not really foresee this one. That should be 0.5. So anyways, let's move on and continue with that one. So we are looking for our P of z less than 0.5. So again, we are going to consider our SSS or the OSA because we are looking for the area. So again, we have here the tail part which is pointing towards the left side. So we have left side direction of your area. And then this one here, the value is positive. It's located on the right side. So we have left, right, they are opposite. So we're following OSA in which we're adding 0.5 and the corresponding value of 0.5 as an area, which is 0.1915. And again, this is 0.6915. So this is equivalent to 69.15%. That would simply mean that there is, or on the question of what is the percentage of the students would take the test for less than 16 minutes. So that's a greater chance. You've got 69.15%. Okay? So I hope that works well for you. So kindly refer to the video also for the different keywords in standardizing with word problems. Okay, so again, that's all for today. I'm hoping that you are doing great and always try your best and work hard in solving the different word problems for standardizing. So in math, really, it's easier as long as you are trying your best. Again, this is your teacher, Jenny, hoping for a great day for everyone.